Check, check. Ooh. Okay, well, let's start the stream here. Yeah, I was expecting we're gonna have a small but a regular group of people, so we don't have too many people here. But I'm gonna start the stream just in case people are gonna watch this after the fact. So I don't know. Start if you have anything in particular that you might want to ask about or stuff you're working on.
I think as of now, I'm good. I need to start the assignments. I'm gonna work on this weekend, so
Okay.
I think I'm good for now.
Okay. I'll jump into things and see if we get some more people show up here. Yeah, for people, I don't think I have anybody join me live yet either. But yeah, I continue to work on hardware issues here. I think I have a bit of a workaround just using my built-in mic. I think that's removed the stutter, although it's not of course, it's not the greatest microphone. But I'll check that again. The last one I did on Tuesday, I know had some issues. Again, I don't know why. I mean, I do know why. It's a new computer, and I'm using an older version of Ubuntu for various reasons. Probably if I just upgrade, I'd get the latest drivers, and I might fix these issues I'm having here. I might do that this weekend. Yeah. Anyway, I mean, sorry for those. Hopefully the video on Tuesday wasn't too bad. People could still use it. Hopefully this one will at least be a workaround so that the audio is stable enough. As far as I can tell, it is stable right now. So, all right. Good morning, Glennon. Yeah. So I'm gonna go ahead and begin. So yeah, as I said, two more people come in, or anybody watching this after the fact. Just announcement or reminders about things. So there's not actually anything officially due this week. I had originally been thinking I was going to give a deadline for people to accept the class project and select a data set by Friday. I might still encourage you to, at least think about it and accept the class project, even if you don't have time to figure out data set. I had one or two people asking questions about things, and looks like they're working on that. So, but yeah, don't forget that. So do accept that class project assignment, and by next week at least. In the next week, have a push committed with the data set that you want to work on. I'm going to try to review those, and to make certain, in general, if you're using a data set from one of the sources I gave, that should be fine. If you're going to be using your own sort of data set, also that's fine, although you do need to discuss it with me. So if you have a personal data set or data set for like you're doing your master's thesis or a project or something like that, those are all good things to work on. If you haven't, I encourage that. Anything you're interested in or more familiar with, always makes a good kind of project for these sorts of things. It'll allow you to do some work on here. It can be useful other places as well. So, but yeah, you do need to, if it's not, in general, if it's not one of those ones from a data set repository, one of those links I gave, I might have to at least discuss a little bit with you to make certain there's not going to be any issue. And there's that, and there is also, though, an assignment, so don't forget the assignment. I'll talk more about that today and next week as we get into things. I know some people are working on that, although I haven't seen too many people accept the second assignment yet. So, if you haven't accepted and started looking at it yet, it'd probably be a good idea to do that as soon as possible here, if you're listening to me or listening to me after the fact on this. Okay, my plan for today, like I mentioned on Tuesday, I thought I'd go back and I've got our 574 class repository running, Jupyter Lab server running with all the notebooks for the lectures and things. I thought I might go back and say one or two things about Matplotlib and Pandas. We never really did talk about either of those. So for the second assignment that you should be working on now, it's supposed to be an introduction to scikit-learn, also a few things with stats model, and also just a first look at the difference between a regression and a classification problem. So all of those ideas kind of come in on the second assignment here. They all kind of come from the end-to-end overview from the chapter 2, I guess it is, from our textbook, on doing an example of a complete machine learning or data analytics sort of project. One thing I remember, I probably did show this in class before. I know some people had a problem with this. Apparently something has changed. So it used to be that you could just, if you're not familiar with these percent commands in IPython notebooks, these are called IPython magic commands. So they're not actual Python code. They are things specific to IPython notebooks. So you can do we'll run across other of these, I think, in our class here. So for one of these, this one sets the back end to render figures from the Matplotlib library inside of notebooks or render them in other places. So apparently, let me try this again. I don't remember if I did show this in class before or not. Let me clear everything out here from this notebook. Let me try this again here. So yeah, that does still have problems. But like I think I mentioned, the whatever the default rendering is, at least for me, is working. So if you just comment that out, and I guess for our notebooks for our assignments, and if I ever had that on any of these other notebooks going forward for these lectures, you might just have to comment that out. So I think in this notebook, if you read it, there was some stuff about you can't actually do like 3D plots and stuff. To do those nicely, you do have to get the rendering back in different than kind of the default one, which is, I think is why I originally had this stuff in here, so that we can change that, so that you could actually, so without this, or without figuring out what the correct way to do it is for the most recent versions of Python and stuff that are being used in these Docker containers, these 3D plot stuff down here might not render, or hopefully it'll render, but you wouldn't be able to do the interactive stuff. So you probably have to use a different backend so that you can interact with these plot, rotate them and stuff like that, which is useful if you're doing 3D plotting kind of thing. So, but yeah, if you just use the default, whatever it is now. I mean, you can check. You have to just do a plot. So usually, you just want these to show up in your notebooks like this, right? And you do have to do a couple of plots in the second assignment. So I can talk about those, but basically, like for the first part where we're fitting a linear model to the set of data, I do ask you to render, to create a plot where you show the raw data points and you show the fitted line that you come up with your model. And I can't remember if we had to visualize. Oh yeah, you do have to visualize some stuff. Another thing I want to talk about, we'll probably talk about it next week. So when you get to the part about doing the classification, so the idea for classification is that the model creates what's known as a decision boundary, which separates one class from the other. So for binary classification, it can be a simple decision boundary that is supposed to separate the decision between yes or no, so rain or not rain. So I'll talk more about that, but yeah, you have to do a little bit of calculations to get the fitted model in order to visualize where the decision boundary ends up being. Although it is kind of, if you got to that point in the second assignment, it's described in there. And I can show some more details of that in case anybody is confused by that when we get to it. So let me see if all the rest of this runs here on the Matplotlib examples. So let's run everything here and below. So yeah, I mean, one thing for me, I always, as I think about things when I'm using stuff, like, when I use notebooks in the Jupyter Lab server and the web-based interface, you can get an idea of what stuff ran or not. You get some indications over here. If you're running a whole notebook, I mean, in general, the outline is a useful thing to use. You can turn on. This confused somebody, at least one person. You can turn on and off the numbers. So for a lot of the assignments, I explicitly number them as task 2, 3, 4. So if you have these on, you'll get different automatic numbers for the headers and the chapters than you will for the what I call task 1 and 2. Oh yeah, 3D plots do work with the basic renderer, but yeah, you can't interact. So you can use a different render, so you can rotate that stuff around and things, which is what I believe. Also as one final quick note as well, if you're interested in this, you can do animations. This is not going to run because you have to have a particular external library, which I don't install by default, but you can easily install that in these containers. Okay, so these containers, so I'm running my 574 Docker container here. That's the thing that's running the Jupyter Lab for my notebook here. Again, this is just a Ubuntu, not Ubuntu, it's just a Linux operating system running inside this Docker container. So it's a plain Debian, pretty recent, newer version of the base Debian than the Debian 12 or not. But yeah, you can just install stuff like you usually would. So should work to get the FFmpeg in there. You might have to do like an update first. But if you're not familiar with doing Unix command line stuff and Unix package management stuff, it's a standard things in Debian-based systems. It uses this thing called app, which is a package manager, so you can add and remove and manage the software that's installed on your Debian Linux distribution. So once you do an update, you ought to be able to get the FFmpeg stuff in there if you're interested in ever doing some animations and things. That was another thing in the Matplotlib library. It wasn't running. But yeah, I don't normally install that because it's relatively big. So if you don't have a lot of disk space or things, you might want to skip it. Or if you're not gonna, don't think you're going to be using it, except for just when you do this notebook. So um, mean, I guess the only other thing I'll mention before I move on from the plotting, this isn't a class about doing data analytics or about doing, visualization of data sets. We touch on a few of those basic things in this notebook. In general, when I ask you to plot stuff, I might complain or I might take off some points or give stuff back to you if you don't do some basic things. So usually, all of your axes should be labeled whenever you do plots. So you should give an idea of what the units are, what the feature is for the x and the y. For a basic plot. If you have multiple elements, we don't have it on this one, but if you have multiple elements, usually there should be a legend which indicates what the different elements are in the plot. And I mean, those are some of the basic things I'll usually ask you about, right? And for this class, I mean, for the assignments, the stuff that's covered in here about creating a basic plot. I mean, mostly we'll just need to use the plot or the scatter. You should use the matplotlib scatter function if you're plotting data points. Scatter there. Let's go to some of the examples here. Yeah, scatter plot. There it is. So the difference. So another thing is if you're just plotting raw data points, those should really be points. So scatter plots are appropriate for those, right? So you want to get an idea of what the actual data is on the independent variable versus the dependent variable, usually in a two-dimensional plot like this. When you're plotting a fitted model, those should usually be plotted as lines. So sometimes I let people plot this as points instead of connecting them up. But the idea for a model, usually like fitting a line with some data, this is an abstraction. So this is unlike discrete data points. This is saying that this would be our predicted height given weight here for the model that we fit on. So I think that was kind of some of the big things I would mention. There are some examples of other kinds of plots in here. I think for the third assignment, there's some stuff you have to do with some bar plots and things. So anyway, if you didn't read through this, when you need to do those things, might work as a reference, but for the most part, you'll need to just be able to do scatter and line plots, and you'll need to be able to apply. So for this second assignment, the very first thing you're going to be doing is plotting the data, and then also after that, after you fit a basic model, plot the resulting line on that data. So the same kind of idea here. But you'll need to at least be able to do that kind of thing for a lot of our assignment tasks. And there is, I probably won't ask you to do any Seaborn plots, but I mean, there are other, most people probably wouldn't normally use matplotlib when you're doing kind of a lot of serious work. You use something a little bit higher, but most of the visualization libraries that you can get in Python, that you can use with Python, are built on top of matplotlib. So they're really just adding on higher level kinds of things. So Seaborn is one that I used to use a lot. It gives things for you can create current density estimates and other kinds of standard sorts of things. Okay. I thought, I would mention a few things about pandas as well, in case anybody hasn't seen the Pandas library before, so we also didn't really talk about this, although this was one of the things that I'd asked you to kind of go through on the previous week. We didn't really have anything on this on the first assignment either, but on the second assignment, you could probably complete the second assignment by just loading the stuff into a NumPy array and doing the things, but some of the things that you're asked to do, like give a summary of each of the features and what their mean and standard deviation is and that kind of stuff. I think that's the very first task you're supposed to do for this second assignment. I mean, you could do this stuff by hand using NumPy, but Pandas is really sort of meant for that, for like loading data. So a lot of the initial exploration of a data set and visualizing things, and we're doing exploration of what's in the data set and what its properties are. And that's really what Pandas is geared for, those sorts of things. So, yeah, I mean, the very first thing you have to do on the second assignment is load in, and I think it is asked that you load in using Pandas. So you load in the set of comma separated values into what's known as a data frame, in order to do the same kinds of things that are shown later on in this notebook, if you didn't go through it yet. So, yeah, it is a library geared towards doing data analytics on typical data laid out as a table where we have samples as rows, and features as columns. So the data frame is really fundamentally a two-dimensional data set, although it can be a little bit more complex than that. But all the stuff we'll do with it in this class is laid out in rows and columns. If anybody's familiar with R, I do some stuff with R sometimes too. This is a thing that kind of came from the R world. So data frame is really re-implementing kind of the functionality of the data frame in the R language originally. So you can do most of the same. It doesn't replicate the API, but the kind of stuff you can do with it, it's similar in R versus Python. I was going to check if this notebook actually runs completely or not. Yeah, so I think that one's running cleanly. So if you look under the hood, I don't know if you'll need if we'll run into this in this class or not, but really a data frame is really just a collection of series. So each feature, each column of a data set is represented as a series, and then the data frame is really a collection of those series instances. So you can create individual what Pandas call series using the series object, but we probably won't go down to that level very often. But this is the basic of what a data frame looks like. So the difference between this and the NumPy array, one difference anyway, is in the NumPy array, I mean, everything has to be the same data type, right? So if I want to read the same data set into a NumPy array, I'm going to have to change all of these into numerical data. So these are kind of string-like. We're using a categorical variable here for the test train. And the other one was just a string data type. And this one has a date. Right? So yeah, you couldn't have a NumPy array with column features all of different types like that. So you either have to throw these away or change these into do a one-hot encoding, or just the integer encoding 012 for test train, 01 for testing train. Right. Another difference is, a Pandas data frame is really meant to be used where you refer to, especially the features, the columns, by a name rather than an index. Right? So normally when we select stuff or manipulate stuff with the data frame, we're going to be selecting by a named feature, so that each column has a column name in these kinds of pandas data sets. Likewise, the rows usually are assigned an index. I mean, they're automatically assigned an index, like happened here, starting at 0. But you can index a data frame in different ways, which we might use once or twice in this class at some point. So something other than just a numerical index starting at 0, like a common thing would be if you have a data set that's really a time series, you might use the timestamp as the index. So then you could select samples by range of a time set of your index, which is time based or something like that. So, I'm jumping around here a little bit on this kind of stuff, just to give some advice. So I do ask you to do a few things in the second assignment, where what you really should be doing is getting a data frame and then doing some of the stuff like is shown on here. So so yeah, right. When you're doing your initial data exploration, you might just use head and tail. So I might ask you to do that in the second assignment here, which is just showing, when we loaded this data frame here, again, we were just creating this data frame by hand. So we created a range that worked as an index, and then 26 different columns with some random data in there. If you work through this example, these were mostly just to show, for example, you probably, if you are defaulting to indexing a feature by an integer index number, you can do that for a data frame like you would index the columns of a NumPy array. But you're probably doing it wrong if you're doing that. So you normally want to, like if I want a particular feature, like feature F, you just want to use the name. So any column name can be accessed on a data frame, single column name, just by all columns are members of the instance of the data frame. So I can get the F feature just by pulling it out like that. Or you can access it this is equivalent. So you can use kind of like an array indexing, but you get column names instead of an integer index if you need to get a particular feature extracted. And likewise, so when you access stuff by rows, since the index by is the default way of thinking of indexes is just a number that I'm starting at 0. It is more common if I need particular samples to index them by their sample number. So this is the same as doing like a head to get the first 3 samples in this made-up data set. But what would be more common is you need to do things with multiple features or doing more complex ways of selecting samples or features. So you can pass on a list, you get a slice of the data frame for some particular feature, DQP in this case. Like I said, you can always go back to using integer indexes, but if you're doing that, it might mean that you're not really using data frames the way they're meant to be used. So a lot of times that indicates you're working against what the library is trying to allow you to do. So you're thinking of it more like a NumPy array than as a data frame with name and features, stuff like that. But yeah, some of the stuff that you be a little bit familiar with now. For NumPy arrays, you can do selecting by Boolean indexing or other kinds of things you might do, right? So, like for example, just creating a mask. But this stuff can be very useful. So here we're selecting all the rows where the M feature is greater than 1 and the X feature is less than -1, which isn't very much. So we only end up with 2 rows that met those criteria. But yeah, once you kind of learn Pandas data frames, you can do very powerful sorts of things in terms of getting particular data that meets particular samples that meet particular criteria to analyze them separately. So yeah, and another thing for data frames, is the big thing for using Pandas data frame or like a data frame in R is, usually when we're doing our data cleaning step, we'll need to be doing stuff that's kind of talked about here in the adding and setting data section of this notebook. So you can do some things really easily. So here we're just getting all the last 3 columns. So I guess we previously added in a cat column, a category column here. Must have passed by that one, but yeah, this was showing an example of how easy it can be to add in like new features based on some properties of other features. This is just made up, but here we're directly in the data frame 2, which is a copy of the original data frame. You do stuff like this. You can either modify an existing feature doing something, or you can add in a new one. So if that doesn't exist, it will create a new column, a new feature called that using this here. So yeah, this is just a random sequence of 1, 2, 3s at the right side. And there's some limitations on this. The number of items in this has to match the number of samples for something like this to exceed, or like it has to be able to be broadcast. So if I gave just one string, it would copy that one string for every sample. So that would also work in some cases. Okay. So I'm just, trying to think about for the second assignment, what kinds of stuff. So like here, we're just so that was what I was just talking about. I can create another column. If you give it just a single value, it'll just copy that. So it's got 2 same string for every sample that we have in this data frame 3 that we have at this point. Okay. So if I think I've mentioned before, so you should always use relative path names. So the very first thing you're supposed to do for assignment 2 is to load in the data set. That was the Magic Telescope data set. So there's one CSV file. So usually, I think I've mentioned this before, all the data set files should be in the data subdirectory. So including for the repository for this class, there are a couple of different data sets that are used in the lecture notebooks in here. So in this notebook for the pandas, we are reading for this class, we're usually using comma separated value files, so CSV files. yeah, I mean, so for your class project, I mean, you'll probably be using a CSV file, but you might have something a little bit more complex. So you might have to have access to an SQL database, or you might need to use an API to do some calls to get data down, that kind of stuff. But this is a basic way of getting data. So if I have it just in a regular flat file with values separated by commas, use this particular function on pandas to read in these kinds of files. So if you look at these, so there is a viewer in Jupyter Lab for viewing these, although sometimes this can be, sometimes you might have to just open this up in like a plain text editor. So if you're working with data that's kind of messy, even the viewer in my Jupyter Lab might not know how to handle it. So you might have to first just open it up in a editor or something much more lower level and examine like a row of data. So most of the assignments for this class, like if I was to look at this one, what I'm saying about that is if I'm having problems with the data set, I could open up in an editor like VS Code. So if we look at data, let's open up that parasite. There it is. So, I mean, here, this one from this notebook for this lecture video is relatively clean. So every line, some data, every line, we're using comma to separate the three values or three features that we have in here. We have something like 351 such data. There is some missing data in here. So some of the stuff down here, even though it's correctly comma separated, there's nothing on the first column for this last one here. I'm sure that's discussed in the example lecture notebook there. And this one has a nice, so one thing that Pandas data frame does is the default is it will assume the first row being read in from a file like this actually represents the feature names or the column names for the data set. So you might not always have that. I can't remember on your second assignment whether we had that or not, the Magic Telescope data. So if you don't have that, or if it's not using commas, so sometimes you have to get additional things, even for a relatively simple comma separate value file, to say, okay, I don't have a header, so use these for my feature names or column names for the Pandas data frame. That's something you might have to do for some of these items. Or it's not using commas, it's using something else. And there's other parameters that you may need to set here. So again, I like using the built-in context-sensitive help. So look at Control I is supposed to do that. I don't know why Control I doesn't seem to work always. So some of the keyboard shortcuts are sensitive to what you have selected. So I guess you have to have a cell selected. Control I. Anyway, so the read CSV, so you can see that these are kind of all the stuff that you can do. So for more complex libraries, you'll get better documentation, Python documentation, functions like this. So some of the stuff you might need to use, like the separator, at some points in our class, whether it's a white space, or the delimiter, I guess, whether it's white space or comma, other stuff. So yeah, by default, it'll use a comma, separator. So I guess delimiter and separator are just the same thing, aliases for each other. You can pass in headers. So if you don't have a header row in the data set, you can specify what the name feature should be for the pandas data frame using this. And other stuff. There'll be other things that you might need to for your, the data sets that you would use for your class project could be potentially messier depending on what you're using, where you get them from. So you'll have to maybe use more stuff like this, or do some initial stuff with the file before you can actually get it successfully read into like a data frame or some other thing to do some analysis with it. Okay. Before last thing on that, do always use relative path names. So again, this is kind of standard practice. So whenever you create projects like this, usually you think of it as self-contained. So within, starting at some top level data, some top level directory structure. So there usually should be subdirectories or folders that hold different parts. And within the project, usually you're always going to be either setting up like a Python path or some environment variable to correctly point to where things are that are needed, or use relative path names. You should never hard code in like absolute path names like that have your username or home directory or something like that in projects like this, because it's not portable. That'll cause problems if you open up another location or if somebody else wants to use it. Right? So usually everything that we do in this class will be like one level up from where we're running stuff. So we'll have to use dot dot, go up one level, and go into the data subdirectory in this case to get like a data file that we're going to read in here. So bring up the second assignment here, talk a little bit about it some more, but there was a little bit like on the second part of it to I think to do some feature cleaning, so to make something categorical, and maybe there was some missing data or something like that, I believe, at least on the second part. So some examples of that are given down in this notebook using this parasite data set, if you haven't looked at it. So, some of the first things you're asked to do is, for example, give a summary of the features. So, describe gives a summary of the numerical features. So, in this data set, they're all numerical. So, there's like 3 features: virulence, replicate, channel diversity. Virulence is missing some stuff, which is probably why it doesn't show up. So, if you looked at the raw data set, you might have been expecting the first column to also show up as a numerical feature here, but it's not showing up yet. And we just loaded it. So let's give basic information about anything that got converted into a numerical feature. So there was 350 samples for each one of these. That was the mean standard deviation and the quartiles of the range here. The replicate, so this makes more sense for the Shannon diversity. The replicate is really kind of like a trial number in this data set. Right? So for virulence, for each one of these, so when virulence was 0.5, they did 50 trials. So there's 50 replications of doing this experiment. It looks like kind of what's happening. And then for 0.6, there should be another 50 and so on. So that means that really, this information about replicate isn't really useful, because it's not really a data point that was collected. It's really like a trial number. But yeah, you'll probably have to do some of the things like this on the second assignment. So, try to figure out what replicate is. The value counts happens because there's actually 7 different virulence levels. So for each one, we have replications 1 through 50. So there's 7 where it was the first trial 1, there's 7 where it was trial 2, and so on. But if you look at the value counts for virulence, there's 50 actual. Okay. Yeah, there is then a discussion on here of, so one of the problems with the data set is there was some missing data on there. So you can see, and that's why the first column was showing up here because it was missing data. It didn't actually initially represent the virulence feature as a numerical feature. NAs or missing data that appeared in there initially. So here, an example of, we want it to do something with that, we can have it say that if something's missing, use a blank instead of a special value. When we do that, we end up getting it to consider virulence to be a numerical feature, but it only has 300 because there's 50 of them missing the data set that we load in here. Okay, yeah, so I mean, that was the main kind of things I just wanted to touch on the pandas data frame. This will all be stuff that you'll need to know. You only need to really know the basics, I think, of pandas for this class. Some of the stuff was also covered in the chapter 2 if you do the reading, because it does use scikit-learn, but also uses pandas, if I remember right, as part of the discussion for reading things in. Let me switch over to assignment 2 for 5 or 10 minutes then. So let me go and close off this one and reopen my second assignment. So yeah, just pulling up the weather data set that we're using here. So there was 365 samples here, and this data set, or 366, but this data set does have a header column. So open it up, the raw here, raw CSV looks something like this actually. So the first column is really just headers, and those are good enough to use as our feature names if you load this into a pandas data frame, and they I think I did give some links, so you get what's known as like a data dictionary or a data description, right? These names give you some indication of what each of these features are. Pretty good indication in some cases, so the wind direction at particular times of the day and stuff like that. But I guess I didn't. So this data set is coming from, I think, like the UCI or one of those, the same kinds of repositories that kind of given as a list of things you can use. So this is one that I would probably reject from you guys using for your class project. In general, there are like basic ones that are used a lot as examples. So like the Irish data set you can find in the UCI or one of the repositories again. The MNIST data sets. So some of those that are commonly used as examples in class like this, I wouldn't allow as your data set for the class project. Just to let you know, it's another reason why I want people to select that kind of early, just in case there's something that I want to steer people away from, to use something at least a little less commonly used. But yeah, this one is coming from there, although I guess I didn't give a link. So you get more information about what each of these features are. Okay, good. So I mean, we've got, I think I've got most of the stuff talked about here that you would need at least to get started, except for we really haven't talked about the stats model stuff. I was thinking I might have, but I'll talk some more detail about that next time, next week as we're doing things. So the first things on the assignment 2, if you haven't started on it yet, is getting it into a data frame. It's not clear on some of these, looking at these. So a lot of the stuff we do give you starting out just stub code so that the notebook will run. Right. So what we're expecting like here is we create one kind of by hand, a dummy one with the features that we need, but you really need to remove that and be loading that into the pandas data frame. So using like read CSV, similar function. That wasn't clear. Similar thing happens on the tasks here. So if it's not clear, you had to do this for the first one, for the first assignment as well. But yeah, when I give you a stub function like this, it'll usually just be returning the everything that's needed, but just default or dummy values for all of it. So normally you have to remove that and be returning the actual stuff when you implement the things for these tasks, right? In later assignments, we might not give you like the stub here, so you'll have to actually add in the function and the PyDoc documentation and maybe uncomment some stuff in the notebook once you get a stub in there. But yeah, you do have to do some stuff with pandas data frames, and then I ask you to do some basic matplotlib, so some scatter plots. And then ultimately, when you fit a line, to do a scatter plot and show the fitted line on there and try and recreate this. So have a legend and label your axes and all those kinds of things. So just practice that kind of stuff. These functions, I mean, they're not really great functions. So a lot of the assignments has functions like this. They're mostly in there so that we can set up the testing. So we have something that we can call with like inputs. You're supposed to be doing stuff in here to fit a model, maybe do some other stuff with the data before you fit the model, and then return the fitted model and maybe sometimes return other stuff. So like in this one, you're not only returning the fitted model, so it's supposed to be a scikit-learn model, but you're supposed to demonstrate here how you query that model to find the parameters that will fit. So the intercept, the slope, and then query it to get some information about how good the fit was. So the mean squared error, the root mean squared error, and this R squared score. Those can all be So after you fit a model, you can get all of those as parameters that resulted from the fitted model. Those also are kind of, so if you go through the chapter 2, you'll see examples of these things. I think most of it is, although maybe not the R square squared. We should probably talk about that a little bit at one point as well. But right, so that's, I mean, that's basically what the tests and what this output. So when you run these tests, it's going to be giving different y's and x's and testing that you're, returning back, getting the exact fitted slope and intercept and values for this other stuff. If you're not doing something quite right, these tests won't pass that we do here. And these things here, if the notebook is running correctly, so again, for the second assignment, you do have to actually do stuff in the notebook, do the plots, do these things that are asked for, to do a little bit of data exploration for the data set. And yeah, it's expecting once it's working that it would just print these out and you would get the expected intercepted slope for the full data set that we're using at this point. Okay, yeah. So I'll go ahead. That's kind of everything I wanted to hit for today. So next week I'll go a little bit over stats model, and probably I'll do a little bit more look at the chapter 2 materials. I quickly brought that up on Tuesday, but we haven't really talked about those. So we'll see if anybody wants to discuss those. But yeah, I mean, although next week we are moving on to the next chapter as well. So besides continuing to talk about assignment 2 and maybe talking a little bit about that in the end example, we'll also need to talk about classification as well. So the next chapter after this, next week, starts talking about classification versus regression problems. All right. Yeah, that's it. Yep, I'll go ahead and stop. I'll see you guys hopefully next week. Let me know if anybody has any questions. Stick around. I'm probably not going to be in office hours today. In case if anybody needs me, yeah, maybe ask me right now. So.